Screen is not visible. Now is it visible? Or should I share it again? Okay, let me share it again. Is it visible to you now? Yeah, it is visible to you. Tell me. Have you done this topic?
Sir, can you explain this again, sir?
This one, once again.
Yes, sir.
Tell me the topic that you have written in the previous class.
Yes, sir.
And I do. Your voice is not coming properly. Is my voice is stuck or is it clear?
Clear, sir.
Nadia, is it clear?
Yes, sir.
Okay. So in the previous class, we were discussing what we were discussing. We were discussing that the chemical properties of metals. Okay. That metals readily do not react. Metals react with water. Okay. Metals react with acids. Metals react with base. Okay. We have discussed this one all.
Yes, sir.
Metals react with hydrogen to form metal hydride. Okay. So we have discussed this one. Today we're going to discuss the next topic is the chemical properties of chemical properties of non-metals. Okay. So let's discuss the chemical properties of non-metals. Okay. This is important topic. Everyone need to understand it thoroughly. And is there anyone in the class who is not having his copy and pen along with him or with her? Is there any student in the class who is not having their copy? I'm going to ask you if whether are you writing or not, if you are maintaining your notes properly or not. Okay. So let me move further. And if you are having any problem regarding to any topic, let me ask you. Please feel free to ask. Okay. So let's discuss. Today we're going to discuss the chemical properties of nonmetals. Okay. Chemical properties of nonmetals. We will discuss first this one. The topic that we're going to discuss today, I'm going to write here. Chemical properties of nonmetals. We will go discuss nonmetals. Okay. Moreover, the second thing that why do non-metals do not react with acid? Why do non-metals do not react with acids? So we will discuss this one. Third point. Today I'm going to discuss the properties of ionic compound formation or Lewis dot structure. Lewis dot structure. And the fourth one, properties of ionic compound. Properties of ionic compounds. And the revision of chemical properties of metal. Chemical properties of metals. We're going to discuss this in this lecture. Okay. So let us start, dear students. So first of all, we're going to discuss the chemical properties of non-metals. Chemical properties of non-metals. Okay. So let us. First of all, we're going to start this one. That what are non-metals? You know that non-metals. What are non-metals? Non-metals are the elements that are electron deficient, having how many electrons in their outer motion? From 4 to 7. Okay. The non-metals, those elements which accept electrons and are electron deficient accept electrons and are electron deficient means they are not electron rich, have electrons 4 to 7 in their outermost shell. You understood? Beta? Everyone understood what I'm saying? For example, For example, chlorine, electronic configuration 287, having 7 electrons in its outermost shell. Oxygen, 2,6, having 6 electrons in the outermost shell. Carbon, 2,4, having 4 electrons in its outermost shell. Nitrogen, having 2,5, 5 electrons in its outermost shell. Sulfur, having 286 electronic configuration, having 6 electrons in its outermost shell. Okay, so these are non-metals. Understood? You understood?
Yes, sir.
Yes, sir.
Please, everybody unmute
Yes,
your
sir,
mic.
understood.
If I ask you that you understood, then everyone in the class has to answer me properly. Okay, that whether you understood or not. I'm having your responsibility. Okay, and I want you to everyone. I want everyone to score very good marks. So for that, what you need to do is, if I ask you to open your camera, you have to open. If I ask you to show me the notes, you have to show me the notes. If I ask you to reply, then you have to reply. Okay, is that clear? So let's move further.
Sir,
Let's
can I
move
note?
further. Yes, Vivian, are you saying something?
Can I note, sir?
You have not noted this one. Note it,
No.
note it, note it fast. Other student, please note it down if you have not noted, because I have discussed this one in the first class when I was just discussing. Note it. Everybody has to note it. We are just practicing. Okay.
That's it.
So, okay, let's discuss, dear students. Now let's move further. Okay. So first of all, the question comes at, we are just discussing the chemical properties of non-metals. So let's discuss chemical property of non-metals. So you know that the non-metals are generally non-metal oxides. You need that if I discuss this one, that non-metals when react with oxygen, they form non-metal oxides. Okay, they form non-metal oxides. So non-metals when react with metals, like metals when react with oxygen, they form metallic oxides. Similarly, non-metals when react with oxygen, they form non-metallic oxides. And non-metallic oxides are generally acidic in nature. It is generally acidic in nature. Why I'm saying it is acidic in nature? Because it is a property that non-metal oxides are generally acidic in nature. For example, if I'm having sulfur dioxide, sulfur trioxide, if I'm having carbon dioxide, carbon dioxide, sulfur
Can you repeat
dioxide,
what you
carbon.
said?
What are you saying? Please pardon.
So can you repeat what you said? I couldn't hear properly.
Okay. I'm saying, wait a minute. Let me plug in this mic so that you can understand. Okay. Is my voice is clearly audible to you?
Yes, sir.
Okay. Now I'm just talking about the sulfur dioxide, the carbon dioxide we have. These are the non-metallic oxides. Carbon is non-metal, sulfur is non-metal. So when it reacts with oxygen, it forms non-metallic oxides. And non-metallic oxides are generally acidic in nature. While, for example, if I'm just going to discuss any property of metals, sorry, non-metals. So then I'm just going to convert the same property, compare the same property with the metals also.
So
For
are
example, if
they
I'm saying the
are they
non-metal oxide.
are all non-metals like is one or
No,
all non-metals
not all. Non-metal oxides, that's why I write generally word, okay?
like most of them?
Non-metal oxides are, yes, most of them are generally acidic in nature, okay? And metal oxides are generally basic in nature. Metal oxides are generally basic in nature. You understood? Basic in nature? Basic in nature, okay? So if I'm going to ask you a simple question that if I'm having sulfur dioxide, it is acidic in nature. If I'm having this metal oxide, like for example, calcium oxide, like sodium oxide, like aluminium oxide, they are acid. They are all acidic in nature. Sorry, basic in nature. They are basic in nature. Like carbon dioxide, acidic in nature. So opposite of them. But you know that I have taught you this one in the previous class, that there are some oxides that shows both acidic as well as basic behavior. And they are called amphoteric oxide. You understood? You remember? What are amphoteric oxides? Those oxides, those metal oxide that shows both acidic as well as basic behavior. So what are amphoteric oxides? Teric oxides.
Show both behaviors.
Those metal oxides,
Those metal oxide which shows the property of both
that
acidic
shows,
and basic
that
are called
shows
amphoteric.
that shows both acidic as well as basic behavior. Okay, basic behavior. So we are talking about amphoteric oxides are only metal oxides. They are not non-metal oxides. Okay. For example of amphoteric oxides, like example was ZNO. We have studied Al2O3, like comma PbO, Al2O3. Okay, Al2O3, comma PbO. Okay. So these are all amphoteric oxides. Okay, these are all amphoteric oxides. You understood? They show both acidic as well as basic here. But you need to keep in mind here, non-metal oxides are not ampho, amphoteric in nature. Non-metal oxides are not amphoteric in nature. Okay, they are not amphoteric in nature. They are not amphoteric. Why? Because they never show acidic behavior. They never show
They can't show
basic behavior. They never show basic behavior. Sorry, they may show neutral behavior. Okay, the non-metal oxide may be neutral. They may be neutral, but never show basic behavior. They are acidic or they can be neutral, but never show basic behavior. You understood?
Yes, sir.
Okay. So moving to this one. Now you understood. I hope you understood. So let you. Okay. Now please note it down that from this one, and non-metal oxide when react with the first property is this one, non-metal when react with oxygen from non-metal oxides generally acidic in nature, but some are neutral. Okay. The important thing that about the non-metal oxide that they never show basic behavior. They are not going to show basic behavior. Okay. And the example of acidic non-metal oxide is sulfur dioxide, carbon dioxide, N2O5. And the example of neutral, they may be neutral also. Example of neutral is this carbon monoxide, this is CO. Okay. Carbon monoxide, N2O, NO, etc. Okay. So note it down, please. Note it down till here. Everyone should write it properly. I'm going to check the answer, check whether you are writing or not. Any students, if it is being asked, show your copy. Whether if you are writing or not, then you will have to show me the copy. Okay, when you are having your camera on. When you're done, please let me know. The N2O5 is nitrous or dinitrogen pentoxide. It is N2O5 is a gas that is of nitrogen, and nitrogen form different types of gas like N2O5, NO3, N2O, NO. Okay, the nitrogen form different types of oxides. Zeba, are you getting my point?
Yes,
Zeba,
sir.
are you doing this first class or is it your first class
Yes, sir.
or this is your first class?
Like for chemistry, it's my first class, not biology.
Okay. So please do it. Done?
No, sir.
Note it down fast. Then the next property of metal is actually, non-metal is non-metals when react with water, what they form? Non-metal oxides, not the non-metals. Non-metal oxides when react with water, what is being formed? So they form non-metal oxides. They form non-metal, sorry, they form acids. You see that is H2, SO2. SO2 when react with water, it forms H2SO3. To keep in mind here that this is SO2 when react with water, so it forms H2SO3. You, this is, if this is sulfur dioxide, then you will get SO3 here. But if we have SO3, sulfur trioxide, when react with water, it will form H2SO4. It will be 4 here. If it is 3 here, then it will be 4 here. So this is sulfuric acid. This one is sulfuric, and this one is sulfurous. If this is 3 oxygen, then sulfurous. And if this is SO4, then it is sulfuric acid. And this is HCO2. You see here, this is 2 carbon. Then 1 carbon will increase here. This will become H2C, and this will be considered as carbonic acid. Okay, you understood?
Yes, sir.
We will give you the backup. We will give you the backup class for this one. Please ask to the management, okay, the review that how to provide the extra class for you. So they will provide you the extra class if you have missed it. Okay, Hashit, you understood? When are you going to have your half-yearly examination?
Sir, mine is in 25/9, sir.
Okay, no problem. So I think I'm going to start the after this one, means this one, the portion from after, means whatever we are going to study today, this will be the last class for this metal and non-metal chapter, because half of the portion is usually come in the examination. The full non-metals and non-metals does not come in the examination in half yearly. So after that, we will going to start with acid, bases, and salts, and we will discuss some important portion of the first chapter also. That is very important that every student must know how to write the chemical formula, how to write the chemical equations. You must know what is displacement reaction, double displacement reactions. Okay. So after this one, we will start acid, bases, and salts. Okay. So be in this batch. Okay. So should I move to the next part? Done,
Yes,
beta?
sir.
You have.
Yes.
Is there anyone who is still writing? Should I move?
No.
Okay. So okay. So let's move further. So what I have written here, I have written that non-metal oxides are generally acidic in nature, but some metal oxides show neutral behavior also. Okay. So now we're going to discuss that the one more property, if I'm going to discuss here, why do, if we have said that metals react with acids, they form salt plus hydrogen gas. Okay. Similarly, metals when react with base, they form salt plus hydrogen gas. Example, metals when react with base, they form salt plus hydrogen gas. Example of this one is Zn when react with HCl. It will give you ZnCl2 plus hydrogen gas. And similarly, when Zn react with NaOH, it form Na2ZNO2 plus hydrogen gas. This is sodium zincate. I have asked you so many times to memorize this reaction. This is very important, very important for the examination point of view. This is sodium zincate. Sodium zincate. You understood? You understood? Yes, student.
Yes, sir.
Yes, sir.
So this is metals when react with base NaOH, they are forming salt plus hydrogen gas. Salt plus hydrogen. If non-metals, for example, if I'm having sulfur when react with HCl, but it form HCl2 plus hydrogen gas. Means does non-metals also react with acids to liberate hydrogen gas? Do you agree? Is there any class anyone in the class? Do you agree this with this one?
What, sir?
Do non-metals react with acids? Is there anyone? Yes or no?
Yes, sir.
Yes.
Okay, let me explain you. No, they will not react. Why? Because let me explain you the process behind this. What is happening
So they
here?
are
If I'm
only acidic, right?
yeah, for example, if I'm having ZSCl when react with magnesium, it form MgCl2 plus hydrogen gas. Hydrogen gas I am writing like this way. H, H, H. Okay, this is hydrogen gas, which is H2. Okay, there is a bond between hydrogen, hydrogen, hydrogen. So what is going to happen? This is an aqueous. Okay, when magnesium ribbon is added to this one. So what is going to happen? This is metal. Metals are electron donor. For example, this is magnesium. It is going to have electron configuration to it too. You understood? You understood? This is magnesium. This is magnesium. This is going to have 2 electrons in its outermost shell. Everybody in the class, if I'm saying understood, then you need to
Yes.
say yes or no. Okay. So if I'm having
Yes.
H positive, if I'm having H positive, so what would happen? This is SCl, if it will be dissociated in H positive and Cl minus ion in aqueous. Where we are having the acid, then acid dissociate H plus ions in aqueous, in water. Okay. So what is going to happen here is this magnesium ion is going to transfer its H plus ion to this one. And this magnesium ion is also going to transfer its electron to this one, this magnesium ion. Why? Because it's wants the stable electron configuration of 2,8. So magnesium, after donating its electron, it will form AMG 2,8 and will become Mg2 positive. So it is happy right now. Okay, MgCl2. Now, what will happen when the H plus ion gets the electron? The charge, if the positive charge will inhibit, because it is one positive charge, when it gets one electron, it will be vanished. Similarly, this one also. So they are going now having the one electron, and they combine together, they form hydrogen gas. So what is being required here and what is happening here is just you need to keep in mind. Do everyone present in the class by your mind?
Yes, sir.
Listen
Yes,
to me what I am saying. What is happening here is this, that the metals are donating their electrons because metals are good. Yeah, we can say that metals are electron donor. So metals are donating their electrons. Metals are donating their electron to the H plus ions of acids. H plus ions of acids and form what would happen when H plus ions get the electron? What would happen? Harshit? It's not from my side. Is my voice is breaking? Is it, or is it clear? Is my voice is breaking, beta? Is there anyone in the class can tell me?
So
Harshit
like,
is saying that my voice is breaking.
so
Is it
like,
breaking?
it's only little bit. No, it's breaking only little.
Little bit now. Okay, let me. So if it change, and let me. Okay. So if I'm having H positive, then what is going to happen here is this H positive ion will get 1 electrons and will form hydrogen gas, H2 gas. Got it? It will form H2 gas, hydrogen gas. So for becoming the H2 gas, the hydrogen ions must convert into hydrogen atoms by gaining the electrons, and form hydrogen gas. So the H plus ions are available in the acids, but they are without electron. They are H plus ions, not the hydrogen atoms. And for forming the hydrogen gas, they need electrons to become hydrogen gas. So what is happening here is that they need a metal that can easily donate its electron. But if I'm having HCl reacting with sulfur chloride, sulfur, HCl reacting with sulfur. So here sulfur is going to have 2,6 electronic configuration, 286 electronic configuration, 286. And it already needs 2 electron to complete its octet. So sulfur is not going to donate its electron to the H plus ions of acids, to form hydrogen gas. Got it? Got it? That's why metals are electron acceptor. They are not able to donate the electrons. So if they will not be able to donate the electrons, the H plus ions of acids, will not react with this one and will not form hydrogen gas. No hydrogen gas will be formed when non-metals react with acids. Got it? Got it? You understood?
So can you explain again, sir? My network internet problem.
Okay. Let me explain one more time. What I'm saying here that non-metals are not able to donate electrons to the H plus ions of acids. For example, if I'm having H plus ions, and this is sulfur, this is 286. So sulfur needs 2 electrons to complete its octet. But here you see that H plus ions, if this is metals here present, like for example, magnesium is in 282. Magnesium can donate electron because it is electron rich. It can donate electron and become 2,8. But sulfur cannot donate the electron to the H plus ions of acids. Why? Because sulfur is electron deficient. It is the element which lacks or which already needs 2 electrons. Sulfur needs 2 electrons. It is electron deficient. It is not electron rich. But here magnesium wants to donate its electrons. So magnesium can easily donate its electron to the H plus ions of acids. Got my point? Got my point?
Yes, sir.
Got my point? So if one more thing you need to keep in mind here is that why do, if someone asks you, if the questions come, my voice is breaking or not, some students are facing problem. But is my voice is clear or should I change my internet connection?
Sir, it's breaking, sir, a lot.
Is okay, let me
Yes.
change the internet connection. Wait a minute. So meeting may be disconnected for a while. Okay, so let me change. Okay, now is it okay? Is it clear? Is it
Yes,
clear
sir.
now? Okay. Now moving to this one is we need to discuss one important thing, that is addition of electron is called reductions. When we are adding electron to anything, so it means that it is being reduced. For example, H when get 1 electron, it form H atoms. Or if we are having 2 H plus ions, if 2 electrons are added, it will form hydrogen gas. So there is a reduction of hydrogen ions is taking place. Means if I'm saying that non-metals are not able to reduce H plus ions of acid to form hydrogen gas, to form hydrogen gas. Okay, so what does it state? Means non-metals are not able to reduce, means they are not able to donate electrons. Okay, got my point?
Yes, sir.
Everybody?
Yes.
Yes,
So
sir.
if I'm
Yes, sir.
saying non-metals are not able to reduce the H plus ions of acid, so it means that non-metals are not able to donate because they are electron deficient. They already needs electron to complete their octet because they are having 4, 5, 6, 7. If they are 7, then it needs 1. If there is 6 electrons, then it needs 2 electrons. If there is 5, then it needs 3 electrons. Okay, so they are already electron deficient. Okay, so they don't donate the electrons. So if the question coming examination that why do non-metals do not react with acids, or why do hydrogen gases not liberated when metals react with acids, sorry, non-metals react with acids, so you have to write this answer simply. Let me give you. So this is the question, that why do non-metals on reaction with acid do not liberate out hydrogen gas? The answer for this one is that non-metals are not able to produce hydrogen gas on reaction with acid. Statement, read it again. Non-metals are not able to produce hydrogen gas on reaction with acid because non-metals are electron deficient. They are not able to reduce. Reduce means they are not able to add. Reduce H plus ion means they are not able to add electron to the H plus ions of acids. Okay. To form hydrogen atoms. To form hydrogen atoms and subsequently hydrogen gas. When one electron is added, it forms hydrogen atoms, and when another electron also comes, another atoms also come, then they combine together, they form hydrogen gas. So subsequently hydrogen gas. While metals are electron donating nature, they can easily donate electrons to the H plus ions of acid and form hydrogen atoms, and thereby hydrogen gas. So note it down, please. Note it down.
So can you go a little up? I can't see the question properly.
What can I?
Can you go a little up? I can't see the question properly.
Now you are able to see this one. Why do
Yeah, the
non-metals on
question.
reaction are
Okay.
not able?
Okay.
Let's note it down. So everyone has to note it down properly, okay? Done?
No,
No.
sir.
No,
Note it down
sir.
fast. Note it down fast. Zeba, you understood?
Yes, sir.
Sure?
Yes, sir.
Sir, what is after while metal are electron?
While metals are electron donating in nature, electron rich, you can electron rich, or you can use electron donating. Donating in nature. And they can easily donate electrons to H plus ions of acid to form hydrogen atoms and thereby hydrogen gas. if you are maintaining the notes and continuously doing the homework, and moreover, you are giving the test honestly, I am damn sure that write my statement anywhere on the notebook that you are going to score above 95% marks in science. Maths
So if
mostly.
this question comes, how much marks will you get?
This question comes, then it will be of 2 or 3 marks. Okay, 3 marks more per day. Got it? So note it down fast. Hami, are you there?
Yes.
Is it your first class now?
No, second class.
Second class. Of chemistry it is first now, or is it second? Okay. So those students who are having means who have missed out their chapter, so don't worry, we'll teach you those one also. Okay, so don't worry about it. Done? Everybody done?
No, sir, 1 minute.
No need to write this one. No need to write this one. And this is just for explanation. Note it first. Done? Yes, you are taking so much time. Should I proceed to next one?
So, yes, sir, okay.
So let's move to the next part is of this chapter that we're going to discuss is the Lewis dot structure. Lewis dot structure. Okay. Lewis dot structure is a structure that used to
So is it
indicate
LEWIS or LOUIS?
LE. It is Lewis. Okay. Lewis dot structure. So actually, what is Lewis dot structure? In this, what we know going to study is this. We generally study that how the compounds are formed. The compounds are formed by either by sharing electrons or by completely losing or completely gaining. Okay. And there are the two types of bonds. One is the ionic bond. Okay, that is bond formed by complete lose and gain of electrons. We will discuss this one. And there was another type of bond is sharing bond. Okay, the type of bond is sharing bond, that is called the covalent, or we called it covalent bond. So we will discuss this one in compounds, carbon compound chapter, so we'll discuss later. So okay, so sharing bond we will discuss in the carbons compound chapter. Now we're going to discuss the ionic bond, that is the bond between ionic bond is the bond that is formed between metals and non-metals. It is the bond that is formed between positively charged ions and negatively charged ions, or it is the bond that is formed by completely losing or completely gaining. Let me explain you. For example, if I'm having sodium chloride, the structure of sodium chloride. So how it is being formed. Sodium chloride, it is Na. We are going to have 281. Another one is the 287, that is of chlorine. Okay, that is sodium and chlorine. So what is going to happen here is this the nearest noble gas, every element in chemistry. What are we studying? Actually, we are just studying the stability of elements, how this compound is stable, why this compound is stable, and why every elements or every compounds wants to be stable. Okay, so in simple language, what I'm going to explain you here is this, that every elements wants to be stable by attaining the electronic configuration to the nearest noble gas. For example, this is sodium. It is going to have the electronic configuration 281, but the nearest noble gas of sodium is 28, and that is neon. Similarly, that is chlorine. Chlorine is going to have electronic configuration 287, but the nearest noble gas to chlorine is, that is argon, and that is going to have electronic configuration 288. So what sodium is going to do in order to attain the electronic configuration to the nearest noble gas and or that of neon? What sodium will do? Tell me. Sodium is going
Lose its electrons.
lose one of its electron.
Yes,
Because
sir.
after losing, it will become 2,8. And what chlorine is going to do to attain the stable electronic configuration to that of argon?
Gain its electrons.
It will gain one electron. That is simple. Okay. So what is and you need to note it down that only the electron of outermost shell participate in the bonding. Participate in the bonding and also represented in Lewis dot structure. Got it? We are not going to represent the innermost electrons, inner shell electrons. So let me explain you what is going to happen here is sodium with one electron in its outermost shell and chlorine with 7 electrons in its outermost shell. I'm going to represent here. Sodium Na with 1 electron and that of chlorine with 7 electrons in its outermost shell. Okay, this is 7. So I have represented 7. This is 1 electron in its outermost shell. So I have represented 1. The inner electrons do not participate in the bonding, so I did not represent it. So what is going to happen? Sodium is going to donate one of its electron to the chlorine atom. And after donation, what would happen? Since sodium has donated one of its electron, it will acquire a positive charge. Why it will acquire positive charge?
Because it's losing.
Because it is losing one of its electron. So losing a negatively charged particle will create a positive charge if we are having equal number of negative, equal number of positive charges. But if we lose one negative charge, then the positive charge will become more in numbers. So simple. If the negatively last charge particle loses or the electron is being removed, then it will become one positive in charge. And similarly, if this chlorine atoms get 1 electrons, so it will get one extra charge, that is negative charge. So this is and what is this now? This is happy. It is going to have 28 electronic configuration. Now it is also happy. It is going to have 28. Now they are not having any issue with them. They are not bonded together. But since they are acquiring the positive and negative charge over them, and that make them tightly bounded together. That is because it has donated. But happily, it is sodium ion is happy. Now the chloride ion is also happy. They are not going to interfere with each other because it is stable. It is stable, but they are tightly bonded together. Why? Because there is a strong electrostatic force of attraction. What is that? Is there is strong electrostatic force of attraction. Strong electrostatic force of attraction. There is a strong electrostatic force of attraction. There is a strong electrostatic force of attraction. Got my point? Got my point? And that is holding this Na positive and Cl minus ion together. That is holding this Na positive and that of Cl minus ion together and form chloride, NaCl. Got it? So if it is being asked that draw the Lewis dot structure of sodium chloride. So first you need to represent this step. Second step is this after representation, after donation of electrons, that is this one. And the third one is this one. Draw this one. And note this point also, that the electrons that are present in the outermost shells are, note this point also, and moreover, please draw the structure of NaCl. Then we're going to discuss some others also. When you're done, please let me know, okay? Nobody is saying okay. Okay, sir.
Yes, sir.
They have muted their mic and I'm just
Yes,
as if I'm teaching to myself. Madia, Zeba, Ashit, everybody in the class. Ammar.
Yes.
Yes, sir.
Okay, noted down fast.
Say them, sir.
Is there anyone also who's still writing? Okay. So what we need to keep in mind is, first, what we need to do is we need to draw the outermost shell electrons. Then after the donation of electrons, and the third one is this. And we have to write the in brackets. It has donated, so it is not having any electron, but it is having 8 electrons. So we have to write like this. So next, moving. For example, if I'm going to draw the structure of I'm going to draw the structure of MgCl2. The structure of MgCl2 can be represented as Mg. How many electrons are there in the outermost shell of Mg? Tell me. What is the electronic configuration of Mg? Wait,
Two.
How many electrons are there?
Two. How to much, sir?
And how many chlorine atoms are there? 2. So place one here and place another here. Okay.
7.
And how many electrons are there in the outermost shell of chlorine?
7.
2, 8, 7. Should I represent the 8 electron or 7 electrons now?
Sir, 7.
Should I represent the 7 electrons here or the 8 electron here? 8. Tell me, should I 7 or 8? Should I represent here 8 or 7? In this one. Tell me, I have to represent the outermost shell. Okay. That is 7. That is 7. Okay. Now, this 1 electron will goes to this one, and the 1 electron will goes to this one. So this is the representation that how electron is being transferred. Now this is the first step done. Now, moving to the second step. What is in the second step we need to do is, this is donated. Donated, then it will become 2 positive.
Sir.
And this chloride atoms. This chloride atoms will gain 1 electrons. Okay. So when it gain 1 electron, it will become what? 1 negative or 2 negative?
2 negative.
2 negative. 1
Negative.
negative.
1
Only
negative.
1. Okay. Now this is donated. Now in the third step, what we need to do? In the third step, tell me. We have to write here Mg, 2 positive in bracket. And then Cl, 1, 2, 3, 4, 5, 6, 7, 8. And how many Cl atoms are there? 2. So I have to write here 2. Got it?
So what about the negative sign?
Now we have to put it here. Please draw this one. Do it fast. Then we're going to discuss the structure of Al2O3. I've written so many topics, but I have not done. Let's We'll take some extra time, okay? Note it fast. Done?
No, sir.
Draw it first.
Done, sir.
Done. Is there anyone who is still writing?
Yes, sir.
Amar, done?
Yes, sir. Yes.
Okay, so let's move further. Now, another structure that usually come that is of Al2O3. Al2O3. So how many illuminated atoms are there? Tell me. 2. If you are not familiar that how this arrangement, whether A we have to put here, O we have to put here, and O how to put. No, let it be. Let it be. Don't get confused, right? Make Al on the one side and O on the other side. If we are having 3 here, then try to put it 1, 2, 3 in between. Okay. Don't try to give 1, 2, and 3 like this. Try from some upper parts, then here and then here. Okay. So that it will become symmetrical. Okay. Got it?
Yes, sir.
How many, what is the electronic configuration of aluminium? Electronic configuration of aluminium. Anyone in the class who can tell me the electronic configuration of aluminium? That is 13. You have to memorize the electronic configuration. I'm going to send you a chart that will going to show you what are the electronic configuration of. Okay. Got my point?
Yes.
So, and that of oxygen is 2,6. Okay. So how many electrons I have to draw for aluminium? Here,
3.
3 because the outermost electron is 3. Here also 3. And how many I have to draw with for the oxygen?
6.
6 because here are 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now I'm going to ask you one question simple. How many electrons this oxygen need to get 8? One oxygen atom needs
2.
2.
2,
So it
sir.
will donate 1 electron to this one, another one to this one. This is 1 remaining. This will be transferred to this one, and this will be also transferred to this one. And the other one is this one and this one. You understood? Understood? Now what is going to happen next? You will get Al again. After donation, you have to show. It will become 2, 3 positive. It will become 3 positive because it has donated. Both of them has donated 3, and they have gained 2 electron extra. Okay. There will be 8 electrons. There will be 8 electrons, and here also 8 electrons. So what is the charge acquired by oxygen by having 2 extra electrons? Tell me, what is the charge acquired by oxygen? Tell me fast.
-2.
-2, -2, -2. This is the first step. This is the second step. What we need to do, the third step is, we will have this Al,
Bracket.
then
Plus
+3, then bracket. Then what we need to do?
and O.
And we have to put 2 because there are 2 aluminium atoms. Okay. And then how many oxygen atoms are there?
8.
8. We have to draw 8 and with 2 negative charge. And how many oxygen atoms are there? 3.
Three.
Okay, now you understand. This is the third step. Have you drawn this one? Everybody? Draw this one first.
Done, sir.
Is there anyone who is still writing? No
Yes.
student.
Yes, sir. Once again, I'm doing it.
Okay, okay. Do this one.
Done, sir.
Done?
Yes.
Yes, sir.
Okay. Now moving to the next part is next part of this topic. Let me discuss the important one. And what was that? Sometimes, so many times this question arises that the properties of ionic compound. This is an ionic compound. That when one electron is completely loosened. Okay, let me write the definition of ionic compound. Let me explain you that what is ionic compound. Okay. Let me write here. I've written, I think I wanted to write. So we're just discussing the topic is the properties of ionic compounds. So the ionic compound is that is formed between positively charged and negatively charged. You can write PO, you can write this spelling of positively and negatively, or you can write like this way. The compound that is formed between positively and negatively charged ions. Okay, that is called ionic compound. Like this is giving example, Mg2 positive is positively charged and O is negatively charged. Or we can say the compound formed by complete transfer, means Mg has donated completely. There is no sharing between these two. Complete transfer, and oxygen has completely gained 2 electron from magnesium. So the electron, so the bond formed by complete transfer or complete gain of electrons. Got it? Got it? And the third one is, here, that is the compound formed between metals and non-metals. But there is an exception of ammonium ions. Ammonium ion is the ions that is, for example, if I'm having ammonium chloride. So ammonia, it is a nitrogen non-metal, hydrogen non-metal, chlorine is non-metal, but it is a ionic compound. It is an ionic compound. This compound get dissociated and form NH4 positive and Cl minus ion. This is an ionic compound, but they are all non-metals. So this is an exception, you can say. Otherwise, generally, most of the ionic compounds are between metals and non-metals. Okay, so we have written here the exceptions also. So please note it down. The chemical properties, properties of ionic compound. Please note it down. Done?
No, sir.
Sir, can you go list it down?
Hmm? Can you?
I
Sir,
can't
can
see
you scroll down?
Okay, okay,
the last part.
okay, okay. A compound formed between metals and non-metal except the compound of ammonium ions. For example, ammonium chloride, ammonium hydroxide. So these are non-metals compound, but they are ionic. When you're done, please let me know.
Done, sir.
Okay, there's one important question that usually comes from this one. Okay, but so it's a prayer time, so let it be. Okay, so going to discuss the next topic in the next class. I have given you in the homework also. Please take the screenshot of this. I'm going to explain this one. Why ionic compounds have generally high melting and boiling point. It is simple that ionic compounds are tightly bonded together. Okay, because you see that this is the positive and negative charges, negative and positive charges. So they are tightly bonded together and they are very tightly hold together. There is a very strong force of attraction between these positive and negative charges. So large amount of heat is being required to overcome this force of attraction. That's why they are able to move freely and come in the molten state. So what is going to happen is this, that why ionic compounds have generally high melting and boiling point. The answer for this one is ionic compounds have generally, ionic compounds, in ionic compounds, ions are tightly bonded together with a strong force of attraction due to positive and negative charges. Okay, that is called electrostatic force. The positive, the force of attraction between positive and negative is called electrostatic force. That's why a large amount of energy is being required to overcome this force of attraction. Means a large amount of energy is being required to overcome, to overcome this force of attraction, and that's why they have high melting and boiling points. Got it? Got it?
Yes.
And similar
Yes, sir.
answers. So similar answers, okay, please take the screenshot. You have to note it down in the copy. Okay, please take the screenshot of this.
Yes, sir.
Taken, everybody?
Yes, sir.
And moreover, there is also, please note it down. Don't forget, because this is very important question. So many times this question is being asked. So no one is going to escape this one. Okay, everyone has to write. Why do ionic compounds are able to conduct electricity in molten and aqueous state? Means why they are able to conduct electricity in molten or aqueous state. They generally do not, means, or the question may also come that why do ionic compound do not conduct electricity in solid state. Means why they conduct electricity only in either they can ask you the question why they can conduct electricity in molten or aqueous state. When the ionic compound is added in water, they are able to conduct electricity. Or it is being asked that why they don't conduct electricity in solid state. So actually this is example of sodium chloride, that is sodium ion, and this is chloride ion here. It is tightly bonded together. They are tightly bonded together. There will be another sodium ion here and then another sodium, and then will chloride ion. Okay. So they are tightly bonded together with a strong electrostatic force of attraction between the Na positive and Cl minus ion. They are very tightly bonded together. Okay. So in the solid state, so that's why they are solid in nature. It is also a reason that why ionic compounds are generally solids, because in ionic compounds, the ions are tightly bonded together with a strong electrostatic force of attraction. So they are generally solid. Okay. So when they are solid, their ions are not able to move freely, because the Na positive is not able to, it is being stuck, Cl minus is stuck. So they are not, the charges are not able to move. The electricity will not be conducted. So if they are free to move, then they are able to conduct electricity. So how they can become free? By adding in water or by making it in molten state, in liquid state. In liquid state, ions are free, they are able to move. So in ionic compounds, ions are highly, this is tightly, okay, are tightly bonded together. Okay, this is tightly. Yeah, beta, you may leave. Okay, tightly bonded together. Take the screenshot. Okay, okay. Ionic compounds are tightly bonded together and they are not free to move. They are not free to move in solid state. Okay. In solid state, they are tightly bonded together. They are not free to move. That's why ionic compounds are bad conductor of electricity in solid state. Okay. Means in solid state, they are tightly bonded together. They are not free to move. If they are not free to move, okay, then they are not able to conduct electricity. But in aqueous state or molten state, ions are dissociated, means they are separated, they are dissociated. So they are able to conduct electricity. Got it? Got it?
Yes, sir.
So the most important line you have to learn is this one. Their ions are tightly bonded together. They are not free to. This is the important one. When the teacher see this line, it might be possible that